All right, so this video is our second day of dividing polynomials. So we're going to start by going through an example of what we did yesterday on day one. Focus this and make it a little bit better. Ooh, that made it worse. There we go. Okay, so our divisor here in the bottom is going to go on the outside of our division. We're going to put the numerator inside. Doing a quick inspection, I saw that I had x squared, x, and my constant, so I knew I didn't need any placeholders in this case. So in order to get 4x squared from x, I need to multiply by 4x. So 4x times x is going to give me 4x squared. 4x times 5 is going to give me 20x. Subtracting these here, no more x squareds. This is going to leave me with 3x and then minus 16. So now in order to get 3x, dividing that in here, I need to multiply by plus 3. So that's going to give me 3x and 15. Subtracting those here. So I am going to have a remainder in this case of negative 31. So I'm going to write my answer as 4x plus 3 minus 31 over x plus 5. And that would be my answer for this first division problem. So the next one we're going to look at here, I have 4x cubed plus 16x squared minus 10, and then 2x plus 8 is what's being divided into that. Doing a quick inspection here, I've noticed I have x cubed, x squared, but I'm missing x. So that tells me I'm going to need a placeholder in this case for my x term. So I'm going to use 2x plus 8 on the outside. And then inside, I'll have 4x cubed plus 16x squared plus 0x minus 10. So in order to get 2x from 4x cubed, I need to multiply by 2 in order to get 4. And then I need to multiply by x squared in order to get x cubed. So 2x squared times 2x is going to give me 4x cubed. 2x squared times 8 is going to give me 16x squared. Subtracting this here is going to leave me with only negative 10, because this will be 0, this will be 0, and I have 0x, so that's actually not helpful in this case. So my answer here would be 2x squared minus 10 divided by 2x plus 8. All right, so those were our basic division questions. Going on here, if it's asking me if a binomial or a monomial or a trinomial is a factor of some other type of polynomial, what it's asking me is if this binomial is evenly divisible into this polynomial, meaning I don't end up with a remainder. So I'm going to start by putting x squared plus 1 outside. So I have 3x to the 4th minus 4x cubed plus 12x squared. I see that I do not have an x term, so I'm going to put plus 0x there. Okay, so in order to get 3x to the 4th here, I need to multiply by a 3, and I also need to multiply by x squared. So 3x squared times x squared gives me 3x to the 4th. 3x squared plus 1 gives me, 3x squared times positive 1 gives me 3x squared. Now I'm subtracting these. You'll notice nothing lines up under 4x cubed, so I need to bring that down. And then 12x squared minus 3x squared leaves me with positive 9x squared plus 0x plus 5. To get negative 4x cubed, I need to multiply by negative 4x. So that's going to give me negative 4x cubed minus 4x. Now because I'm subtracting, I'm doing the opposite. So this will leave me with 9x squared plus 4x plus 5. And in order to get 9x squared from x squared, I'm going to do plus 9 up here at the top. Multiplying through, I have 9x squared plus 9. Subtracting both of these is going to leave me with 4x minus 4. Oops, ran out of room on the screen. So, since I have a remainder here, my answer is no, this is not a factor, because I have a remainder and my remainder is not 0. All right, we've got a couple more to look at here. All right, now I have a binomial divided by another binomial, but this binomial is x to the 5th, so I'm missing x to the 4th, x cubed, x squared, and x. So I have 4 placeholders I have to put in this one. So I've got x to the 5th plus no x to the 4th plus no x to the 3rd plus no x squareds plus no x's minus 32. Now it's very possible that I'm not going to end up needing every single placeholder, but I'm always going to put them there when I'm doing long division of polynomials, just in case. All right, so here I'm going to need x to the 4th. So x to the 4th times x gives me x to the 5th. X to the 4th times negative 2 gives me negative 2x to the 4th. Subtracting these. So I'm going to get 2x to the 4th plus 0x cubed. And for right now, I'm just going to bring down one at a time. So in order to get 2x to the 4th, I need 2x cubed. So multiplying both of those terms by 2x cubed gives me 2x to the 4th minus 4x cubed. Subtracting both of those gives me 4x cubed plus 0x squared, bringing down my next term. Excuse me. So I'm going to need 4x squared in order to multiply this first term to get 4x cubed. So I'm going to have 4x cubed, and then 4 times negative 2 gives me negative 8x squared. All right, it's going to be a long one. So this is going to give me 8x squared plus 0x. So I need to multiply by 8x in this case. So I've got 8x squared, and then 8 times negative 2 gives me negative 16x. Doing the opposite here, 16x minus 32. In order to get that, I need to multiply by 16. So multiplying here, I've got 16x minus 32. Doing the opposite gives me a remainder of 0. So x minus 2 is a factor of x to the 5th minus 32, and it gives me x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16, and that would be my final answer. All right, here we go. Is x to the 4th minus 1 a factor of the polynomial x to the 5th plus 5x to the 4th minus x minus 5? If so, write the polynomial p of x in fully factored form. All right, the first thing we need to figure out is if x to the 4th minus 1 is even a factor. So I've got x to the 5th plus 5x to the 4th. I have no x cubed, and I have no x's, so I got to put some placeholders there. Minus x minus 5. All right. So here I'm going to need an x. X to the 4th times x is going to give me x to the 5th. That place is all the way down there. So x to the 4th times x is x to the 5th. X times negative x gives me negative x. Subtracting these and doing the opposite. So I have 5x to the 4th, 0x cubed, 0x squared, no more x's, and then minus 5. This is going to be 5 in order to get 5x to the 4th. So I'm going to have 5x to the 4th minus 5, doing the opposite. It's going to leave me a remainder of 0. So in this case, yes, x to the 4th minus 1 is in fact a factor of the polynomial. So I know that one of my factors is x plus 5. So one thing we do have to do is check and see if x to the 4th minus 1 is in fully factored form. Now, if you had me when you were in Math 1, we talked about how to factor something that had perfect squares. So I'm going to come over here. X to the 4th minus 1. Well, 1 is a perfect square because I can do 1 times 1. And remember, one of these does have to be negative. And x to the 4th is actually a perfect square because I could do x squared times x squared. And of course, my document camera froze. There it is. All right. So this would be x squared plus 1 times x squared minus 1. And this is the factored form of x to the 4th minus 1. Well, now I have to double check and make sure both of these are fully factored. Well, x squared plus 1, that's as factored as we can get. But x squared minus 1 kind of looks a little bit like this, which tells me I can factor that one further. So this would be x plus 1 and x minus 1. So this technically is the fully factored form of my polynomial p of x. And all of this stuff here at the end, if you multiplied it all back out, would be my x to the 4th minus 1. All right, we got one more. I have x cubed plus 6x squared plus 11x plus 6, which represents the volume of a box written in cubic inches. We know the width is x plus 1 inches, and our goal is to determine what the height and the length would be. This is going to end up being super similar to our last question. So technically, what's happening here, if you like to see a picture, I don't know how good my box drawing skills are going to be, but we'll pretend. So I know that this is x plus 1. I don't know the height, and I don't know the length. But I know if I multiply all three of these things together, I get x cubed plus 6x plus 11x plus 6. So the first thing I'm going to do is I'm going to divide x plus 1 into my volume statement. And that's going to tell me what I have left over after I divide this out. That would be the width, or excuse me, the length times the height. So x times what gives me x cubed? Well, that would be x squared. So x squared times x gives me x cubed. And then this would be x squared. So this is going to leave me with 5x squared plus 11x plus 6. So I need 5x in order to multiply to give me 5x squared. And then that would be 5x. I'm going to subtract those here. This is going to give me 6x plus 6. So I need plus 6 here, which is going to give me 6x and 6. Subtracting those is going to give me a remainder of 0. I had to get a remainder of 0 because I know this is a factor of this polynomial because the length times the width times the height gives me volume. So x squared plus 5x plus 6, that represents the length times the height. So I need to factor this statement here in order to get the factor that represents length and the factor that represents height. So if you think back to how we did our box method, since my coefficient of A is 1, I'm looking at multiplying to get 6 and adding to get 5. Well, the only way that that's going to work is 3 times 2. So that tells me one of my factors is going to be x plus 3, and the other is going to be x plus 2. So these two expressions here are the length and the height.